Good evening and welcome. Thanks for joining. We're going to be exploring the exciting world of high pressure boilers and their steam systems. I apologize for the poor lighting, the poor sound quality, and for someone who's not personally a very good public speaker. However, I am using this as a study tool and thought that it might be beneficial to document the process, and then also have the information as a resource in case others found it useful. So today we're going to be talking about steam systems. This is a educational and artistic video. If you would like to subscribe, share, or support my content, I do have a Bitcoin or Ethereum address listed below. So let's dive right into steam systems. Typical components required for operating a steam system include superheaters, desuperheaters, pressure reducers, turbines, steam traps, condensate return components. Superheaters increase the heat content of steam for use in steam turbines, while desuperheaters reduce the temperature of steam to be used in other auxiliary equipment. Pressure reducing stations reduce high pressure, steam to the lower pressure required for processes. Turbines use steam to generate electricity. Steam traps increase the efficiency of plant operation. Condensate tanks with booster pumps collect the condensate for return to the boiler. That's a pretty excellent explanation. I'm going to read through that again. Typical components required for operation of a steam system include superheaters, desuperheaters, pressure reducers, turbines, steam traps, condensate return, heat exchangers. Superheaters increase the heat content of steam for use in steam turbines. We know that's a fact. In turbines where they're generating electricity, a superheater is going to be used. That will most likely be on the exam. Pressure reducing stations reduce high pressure steam, so lower pressure to the lower pressure required for a process. Better choice of words. Turbines use steam to generate electricity. Steam traps increase the efficiency of plants. And condensate tanks with booster pumps often collect the condensate for return to the boiler. So yes, that's a great general explanation of an operation of an steam system, especially using high pressure boilers. So we're going to start talking about steam. Saturated steam is steam that is in equilibrium with water at the same temperature and pressure. Auxiliaries such as reciprocating pumps, saturated steam turbines, heat exchangers are designed for saturated steam. Process steam is also saturated. Superheated steam is steam that has been heated above the saturation temperature. Superheated steam contains more heat energy than saturated steam because it is at a higher sensible heat, has a higher sensible heat content. Superheated steam contains more heat energy than saturated steam because it has a higher sensible heat content. The boiling point, saturated steam. The boiling point of water depends on the pressure. When the pressure increases, the boiling point also increases. For example, Water boils at 212 degrees Fahrenheit at 0 psi. 227 degrees 0.4 Fahrenheit at 5 psi, and 338 at 100 psi. This will be on the exam. I guarantee, for example, water boils at 212 degrees Fahrenheit at 0 pounds per square inch. 227 Fahrenheit at 5 pounds per square inch, and 338 Fahrenheit at 100. And those are pretty easy numbers to remember. 0, 5, 100. Even if you aren't great with numbers like myself. Not a strong math person. Saturated steam is in equilibrium with water at the same temperature and pressure. Saturation pressure is the pressure at which water and steam are at the same temperature. Saturated steam is in equilibrium with water at the same temperature and pressure. Saturation pressure is the pressure at which water and steam are at the same temperature. Saturation temperature is the temperature at which water and steam are at the same pressure. The saturation temperature increases as the pressure increases. Initially, steam power plants that used reciprocating engines were designed to operate with saturated steam. Steam operators were introduced between the boiler and the engine to remove condensate from steam. This improved the quality of the steam but did not remove all the moisture. Drawbacks to using this wet steam included erosion of engine parts, loss of heat to metal causing condensation of steam, and erosion of lines and fittings caused by impingement of the steam. Steam impingement is the condition where steam strikes a metal surface, causing erosion on that surface. These drawbacks were almost eliminated by the use of superheated steam. So steam quality may be either wet or dry. Boilers generate steam to be used in a load. Heat energy is extracted from the steam when it is put to work. When any heat is removed from the saturated steam, a portion of the steam condenses into a liquid state. If there are water droplets in the steam, it is wet steam. If there is only steam with no condensation or carryover, it is dry steam. Steam quality is the ratio of dry steam to the total amount of water evaporated. If steam has a quality of 98%, it is 98% vapor and contains 2% water. A throttling calorimeter is used, I hope I'm pronouncing that right. Anybody else can jump into the comment section later and correct me, or I will have email eventually for all these accounts if you ever would like to email me about covering a topic in a future video. Throttling calorimeter. I am not pronouncing that right. Calorimeter is used to directly measure the moisture content in steam. The heat content of steam does not change when steam expands without doing work. The heat content of steam does not change when steam expands without doing work. When dry steam is discharged to the atmosphere, it becomes superheated because the temperature is above the saturation temperature. When wet steam is discharged to the atmosphere, some work is done as the water evaporates to steam. This reduces the temperature of the steam, and the reduced temperature at atmospheric pressure can be compared to the saturation temperature to determine the steam quality. Superheated steam. Yeah, we'll go into superheated steam. Superheated steam has been heated above the saturation temperature without a change in pressure. Superheaters are used for loads that require dry steam. Superheated steam contains more heat energy than steam. Therefore, superheated steam can produce more work than saturated steam can produce at the same pressure. For example, saturated steam at 100 psi has a temperature of 338 degrees Fahrenheit. If this steam at 100 psi had a temperature higher than 338 degrees Fahrenheit, it would be superheated steam. So below 338, saturated steam. Above 338, superheated steam. The degree of superheat is the difference in temperature between the saturation steam and the superheated state of the same steam. In an average steam turbine, there is a gain of about 1% in efficiency for 35 degrees Fahrenheit of superheat. For example, if superheated steam at 100 psi and 338 were heated to 500 degrees, it would have a superheat of 162, 500 minus 338, that's easy enough. This equals about a 4.6% increase, and in some designs, the increase can go as high as 15% for 200 degree Fahrenheit of superheat in larger turbines. We're hitting 12 minutes, and I've been talking for a while, and y'all have been looking at me for long enough. I think it's time for a margarita as a reward. I hope you all have a positive and productive day tomorrow. Thank you for joining and sharing my time. I hope that you benefit, and stay well.